Project configuration, network chaos, and spanning tree to the edge. By the time we're done here, you will blow up a network without spanning tree and create a game plan for the future. Let's jump right into our paper napkin network diagram, and I want to start off with a question. Do you like being surprised? Depending on your personality, there's probably a variety of answers you could give, and probably the most common would be, well, it depends on what the surprise is. And I totally agree with you. But I will tell you, one area you don't want to be surprised is in the realm of networking. There's very few feelings that are worse or more stressful than the whole network being down, all eyes turn to you, and you have no idea why. That is a nerve-wracking, cold sweat-producing, disgusting place to be. And that's what I want to talk about in this nugget. The reason I've been emphasizing spanning tree protocol throughout this series is that's one of the fastest ways to bring an entire network down to its knees. And I also want to bring this switch into the picture because I know somebody has watched this entire series and probably had the question, how is that switch okay? Jeremy, did I or did I not see you beat a switch senseless earlier in the series that was sitting on somebody's desk? And I would say absolutely yes, and I do stand behind my act of savagery against that switch. This switch represents two things. First off, it represents you and I, meaning we're not normal users. If this was in a normal user cubicle or in an office where it's in the open like that, chances are very good eventually it's going to get unplugged and it's going to cause an outage or somebody's going to trip over the cables. It's just not in a good space. Anytime you have a switch like this in an open space, problems occur, except for you and I, meaning we're going to need a lab environment. We're going to need a space in our IT room where we can plug things in and test things out and so on. So that's the first thing this switch represents. The second thing it represents is an additional switch in the IT room. Meaning, up till now, I've been calling these and these the core of each office suite. Suite 1 has a core of 2 switches, and that's these guys, and then the access switches would connect from there. Suite 4 has a core of these 2 switches, and then the access switches would connect from there. The 2 cores are redundantly connected, and as we connected in access switches like this guy right here, we would do so resiliently. Now in this case, I demonstrated configuring a lag to my office because I wanted one. But if this was actually in the rack, this ES8 would have a single connection to each one of these switches. That way, if either one of the core switches went down, the ES8 would stay online and still be able to reach the rest of the network. So what I wanted to talk about in this nugget is, should this switch be configured for spanning tree? If so, how should it participate in all that? And what goes wrong when you don't configure it correctly? And one more thing, if something does go wrong and your network blows up, what do you do to find it? So the first thing I want to do is go to this EdgeMax switch, this Ubiquiti switch, and get logged in. I did update the username and password since we implemented it, so now I've got a little more secure login. Now there's not too much configuration on here. All I really have going is the lag, and you remember a couple nuggets ago we went in and configured the lag with ports 7 and 8 on the switch. And that's going to be these 2 red cables right here that go to the wall jack and feed back to the SG300. But at this point in time, this switch hasn't really entered the spanning tree discussion at all. We don't even know if it's running spanning tree. So let's head over to the switching tab right here and find, there it is, spanning tree. So let's just click on that right there and we go to the main spanning tree page and you can see the spanning tree admin mode is set to enable. And right there is the 3 different flavors of spanning tree that we have available to us. If I were to translate these IEEE standards back to their normal names, 802.1d is classic spanning tree. That's the old, really slow one. That's probably the most widely supported, but slowest to solve a problem if there is one. Next to that is rapid spanning tree. That's 802.1w, which took all the good things of classic spanning tree and made it faster. They then released multiple spanning tree, or MST, 802.1s, where you can have spanning tree do tricks in VLAN environments. We'll talk all about that when we get into the VLAN series. The beauty is these are all backwards compatible with each other. Multiple spanning tree or 802.1s is backwards compatible with 802.1w, which is rapid spanning tree is backwards compatible with 802.1d. You just don't want to run that because it has to kind of downgrade itself to the slower standard if you do have that in your environment. But all that being said, what do I see out of the box? This thing has spanning tree enabled. And that's a great thing. Unless you want to blow up the network like I do right now. So I'm going to go in and disable spanning tree. Now, I want to make sure that you catch, disabling spanning tree in itself doesn't blow up the network. It just makes it vulnerable to loops. It's not going to detect a loop if it does happen. And that's exactly what I want to do. So I'm going back here to this switch right here. First thing I want to do is I like blowing up networks, but not when people are impacted. So I'm going to unplug these two cables right there. And I know someone out there is like, oh man, come on, make it good. Well, yeah, okay, you do that on your network. So I've got this switch isolated from the main network. I've got my computer, and this is actually a little NAS I have plugged in, which just runs over there. It's my storage where I store a whole bunch of stuff, right? So right now, the only thing that's plugged in is my computer. And I want you to notice the light right there. Let me move my camera over. Do you see kind of the feel of the light? And I know this sounds weird right now. It's just kind of there, right? It's solid. Every now and then it blinks, and that's pretty good, right? So I'm going to take this conveniently placed Ethernet cable, which is just a short cable, and connect one end here, snap, and one end right here, snap. Now, I know you might be thinking, who in their right mind would do that? Why would you plug in a network cable with this kind of loop thing? And I will tell you, it happens all the time, especially if you leave one of these out in the open. You might have a nice long network cable that's run across the floor and nobody knows where it goes. And a well-meaning person walks along and they go, oh, look, there's a network cable. It probably goes in right there. And snap, they cause a loop, and they can't even tell it's a loop because they don't even know what a loop is, much less know that that same cable is snaking around the cubicle and back to the other side. It's that easy. Now, what I do want you to notice is look at those blinking lights. What did you notice compared to what it was before? Previously, it was just kind of a solid green, and it blinked every now and then. Do you see something different? They're all blinking in unison. Right now, there's a network storm happening in this switch. I'm going to show you something. Watch this. I'm going to go onto my computer, which is the one I'm talking to you on right now, and open Windows Task Manager. You see all my programs that I have running. I want to go straight over to the Ethernet port. Look at this. It is don't double click it. It is receiving 398-ish megabits per second. It's now going into the 400. What is that? That is a broadcast that is looping around the network time and time again. Let me reach down here and unplug one of these loop network cables and watch what happens to the network traffic. Isn't that insane? It's like nothing. Then I reach back down here and plug this network cable in again. Wait for it to come up. Now, my computer's probably being pretty quiet. Let's do this. I'm going to open a command prompt, and if it's not sending a broadcast on its own, I'm just going to ping something. Let's ping, we'll just do 10.225.1.1, right? That's going to cause an ARP message because it's going to say, hello, who is 10.2? That's a broadcast. And what do you see happen? As soon as I do that, bam, it's back up at 541 megabits per second. That is a network disabling event. Now, here's the problem. I'm going to go back to my command prompt here and just do a quick ping to 10.225.1.244, which is my switch. What do you see there? It's down. Now, wait a sec. I'm looking right here. The switch is blinking rapidly. I mean, obviously it's online. I'm seeing 500 some megabits per second of network traffic. How can it be down? It's not down. Well, the problem is that switch is so busy processing all these broadcasts. I mean, this thing has a tiny little processor. It's not meant to handle this kind of stuff. It's so busy that it can't even respond to pings. My friends, this is a network outage that if I had these red cables attached, this same kind of event would be happening for every computer across the network. Now, I'm saying every computer, but every server, everything else. Now look at my computer. It's sitting there at 24% CPU utilization. Now, that's simply because this is an i7 processor with 8 logical processors. It's probably got those things just sweating to keep up with all of the broadcasts that are there. But not everything has an i7 processor with this much power. So you will see the lower powered devices like your wireless access points, your video cameras, your normal user computers, your lower end servers, they're all locking up just like this switch did. Now here's the problem is you can't even get to the switch, meaning I'm like, oh man, I want to enable spanning tree. And I'm sitting here like, oh come on. Oh, matter of fact, it's still open. Let's just hit the submit button and it should, why is it still loading there? Come on, just fix yourself, switch. I'm looking, it's still blinking, it's loading, The switch is incapacitated. Most of the time this happens, there's only one way to solve it, and that's to find the cable that is causing the loop and disconnect it. Now, I want you to notice that rhythmic pattern of the lights, because if this was happening network-wide, you would walk into your server room in the IDF or the MDF, and you would see that same rhythmic pattern across all the ports in your system, or at least a large majority of them. And look at that, our switch finally timed out. Well, I'm going to reach down and grab that network cable and disconnect it. And we should see that broadcast storm stop. That's a broadcast storm. I want to come back to the questions I started this nugget with. How should this guy be configured for spanning tree? And if you have a loop like this occurring, how do you stop it? And once you hear my answer to that, you're going to have the follow-up question in your mind. Is there anything that I can do proactively to stop a loop before it happens? And that's the right question that we want to land on. So let's hit that first question. How should this switch be configured for spanning tree? Well, now we can see it's responding no problem at all because there's no network loop happening. I'll make two statements on that spanning tree configuration. The first is that it needs spanning tree, period. That's why I went crazy and obliterated that small little switch, is because I know that switch does not support spanning tree, and it's a loop waiting to happen. The good news is once you moved into a managed switch like this Ubiquiti Edge switch or a Cisco switch or whatever brand you want to throw down there that supports a managed switch capacity, you gain the feature of spanning tree. So rule number one is that spanning tree is enabled on every single switch in your environment. Rule number two is that these edge switches, meaning those not core to your system, a lot of people would call these access switches, are configured in such a way that they would never become the root bridge. And how do you do that? Simply by setting the priority of your other switches lower than the default. In our case, we set this guy to 4096, and we set this guy as kind of a backup at 8192. That's their spanning tree bridge priority. This guy and every other industry standard switch that you pull out of the box will have a default priority of 32,768. We can verify that by jumping in here, and the Ubiquiti switch, I believe, goes under common spanning tree where its bridge priority is. Now, initially when you see this and when I saw it, I was like, 8,000, that's not good. That's not industry standard. But they're doing it in hexadecimal just because they wanted to. If you were to go to Google and type in hex to decimal, I'm sure there's a calculator quickly available where you can type in 8,000 is my hex value and the decimal is 32,768. So this is an industry standard configuration. It's just they put it in hex rather than decimal. By having that higher priority than your core switches, you're assured that this one will never become the root bridge. Unless the whole core system is down, and then at that point you don't really care who the root bridge is. Everything's down. Now, I know some of you are thinking, what if somebody comes in and maliciously sets their priority lower than even your core switches? Yes, that can happen, and yes, that is a security threat. And that's something that I would talk about when I created an IT Expert security series. For now, we'll pretend that this world is a happy place. So now I want to hit my second question. Okay, the network's down, all the lights in the IT room are pulsing. What do you do? That is where you need your network diagram like oxygen. Let's say that you and I walked into Suite 4, we see the switches pulsing, everybody's screaming, the network's down, I can't work. The first thing that you're gonna do is unplug that. And you're gonna see if the pulsing stops. Why would you unplug that? Because you know that's an uplink to another switch. And you also know the whole network is down right now anyway, so it's not like you're causing a bigger outage. So you unplug that cable number 1 and the pulsing is still going. What do? You unplug cable number 2. You now know that the suites are completely physically separated. Now, if those switches are still pulsing, what does that tell you? It tells you that the loop is happening right here in suite number 4. If you'd like to confirm, you can walk your way down to suite number 1 and look at those switches, and the chances are pretty good that they have now stabilized if these guys are continuing to pulse. You then unplug these cables, and at that point, chances are pretty good one of these switches is going to stop pulsing, right? And what does that tell you? Well, whatever switch stopped pulsing would indicate that whatever's plugged in there is not causing a loop. The switch that continues to pulse is your culprit. And now you start going cable by cable. Unplug, pulsing stop, nope, plug back in. Unplug, pulsing stop, nope, plug back in. You keep going down that chain until you finally find the one that when you unplug it, all the pulsing stops. You grimace and shake your head at the cable. Look at your cable map and walk to whatever office that cable leads to. And that's where you get your best, I'm a jerk IT guy look about you. You walk in there shaking your head, spit on the carpet. You know where I'm going with this, right? Something happened, and then you find out that's your office. Oh, quick, make something up. There was some bad firmware. If a loop is happening, unfortunately, the network goes down. So the only way that you can figure out where it's at is getting physical with the switches, plugging and unplugging network cables. Now, let me tell you what's happened to me in the past. I've had network diagrams that are awesome, and they were stored on the server connected to the network. So when the network went down, I'm like, oh, I'll just access that server and get my network diagram. And you know how that story ends, right? All the work that you put into that network diagram is worthless because you can't get to it. The network's down. All the more reason to, number one, print a network diagram, throw it in a little laminated piece of paper and stick it in the IT room, MDF or IDF, or keep a locally accessible copy somewhere. So now I want to answer that last question. Is there anything that I can do to keep this from happening in the first place? I mean, if it's that easy that somebody can bring in a switch and just, take a network cable like that and cause a loop in the system, that doesn't make me feel very warm and fuzzy. Well, me neither. And the good news is absolutely yes, there is something proactive that can be done. I'm going to go to our Cisco switch, which is any one of the switches that you have, because if a switch supports spanning tree, chances are good, and I'm going to say fair to good, because I've seen some lower end switches that don't support this, that they will have a feature called BPDU Guard. So let's get logged in here. And I'm going to come over here to Spanning Tree, and let's look at the interface settings. Now I see all of the different switch ports right here, and unfortunately they just have a radio button, so it seems kind of like you have to go one at a time. So I'm going to go port number 1 and scroll down and look at Edit. And when I pull that open, I can see that right here is BPDU Guard. By default, it's disabled. What this lovely feature does is shut down the port if it ever receives a BPDU. Now, Jeremy, remind me again, what is a BPDU? It's a Bridge Protocol Data Unit. Every switch running Spanning Tree Protocol sends these things out all ports once every 2 seconds. You might remember I told you this is like their network sonar that they use to detect loops. So if I went onto this switch right here and turned on BPDU Guard on port 28, it would see the BPDU message coming from the root bridge, and it would say, I'm sorry, I guard against that because that could cause a loop, and disables it. Now, in this case, we wouldn't want that. We would say, no, I don't want to enable BPDU Guard on this port or these ports, or that port, or any one of the ports that connect to our known good switches. But I do want to enable it on every single port that connects to an unknown. And who are the unknowns? Every cubicle, every office, every place that you have in the system that is not one of your known ports. So let's say somebody took a little switch and plugged both of these cables in, and this is an unmanaged switch. What will happen? Well, this switch will send a BPDU out, and it will hit this and loop right back around. So what happens? This switch gets its own BPDU back, and BPDU Guard steps in and says, disable. That link is now terminated until you, the administrator, gets involved to turn it back on. I love that. Now, I promise that you would be able to blow up a spanning tree-less network environment and create a game plan for the future. So this lab objective is as wide open as you can get. I want you to configure an additional switch for Spanning Tree. I want you to blow something up. I want you to fix it. I want you to play with BPDU Guard. I want you to configure alternate root bridges in case the primary goes down. I want you to live in a sandbox called Spanning Tree Protocol. The more you chew on it, the more delicious it will become. I hope this has been informative for you, and I'd like to thank you for viewing.